Why use shadow deployment for ML model monitoring? Have you ever wondered how companies ensure their machine learning models work perfectly before they go live? One effective method is shadow deployment. This technique allows teams to test new model versions without affecting current users. Let's break down why this approach is beneficial for monitoring machine learning models. Shadow deployment works by sending the same input data to both the existing production model and the new shadow model at the same time. However, only the output from the production model is shown to users. The predictions from the shadow model are recorded for later analysis. This setup allows teams to compare results and spot any differences without disrupting the user experience. One major advantage of shadow deployment is risk reduction. Since users only see the production model's output, any errors from the shadow model do not impact them. This means teams can test new features or improvements without worrying about negative effects on users. Another benefit is real-world validation. Shadow deployment tests the new model in the same environment where it will eventually run. This means it uses actual input data and traffic patterns, providing more reliable results than offline testing. This real-world approach helps teams understand how the model will perform once it is fully deployed. Performance comparison is also a key reason to use shadow deployment. By looking at the predictions from both models, teams can identify improvements or regressions. If the shadow model performs better, it can be a sign that it is ready for production. If not, teams can investigate and address any issues before making changes. Early detection of problems is another important aspect. Continuous monitoring of the shadow model's outputs can reveal issues like data drift or changes in features that might affect model quality. This proactive approach allows teams to fix problems before they become serious. Finally, shadow deployment simplifies the rollout process. Once the shadow model proves to be reliable, switching it to production is usually straightforward. This often involves just redirecting traffic or toggling a feature flag, making the deployment process smoother and less risky. In the context of artificial intelligence tools like ChatGPT, DALL-E, and Midjourney, shadow deployment is essential when updating models that generate content. It helps ensure that new versions maintain or improve quality and ethical standards without disrupting user interactions. In summary, shadow deployment is a smart strategy for monitoring machine learning models. It allows teams to test new versions safely, validate performance in real-world conditions, and detect issues early. This approach supports responsible development and deployment of artificial intelligence technologies.